Hi, let's do one last example of momentum and impulse word problems. So, in this problem, we have an inflatable landing cushion placed beneath a 45.5 kilogram stunt double who jumps out of a helicopter. By the time the stuntman reaches the cushion, he is traveling at a speed of 24.0 meters per second. What stopping time is needed to safely bring the man to rest with a force of 2,350 newtons? So, we have a situation here. This is the before picture, and then the after picture. I haven't quite finished that one yet. Um, and I'm also labeling my pictures a little bit too, just to show, what speed they were going at and the mass and everything. I do have one little extra detail that I need to add here, and that is the direction. Because impulse and force and momentum and velocity all are supposed to be vector quantities, we have to keep in mind the direction every time. And so, because of that, since we're moving down, traditionally down is negative. And so, I'm going to label my velocity at the beginning as negative 24.0 meters per second. That matters a lot because we will see later when we do some subtraction and moving things around, we have to have the directions correct or else we'll get some weird answers. So when I label all my numbers down here, I want to make sure my velocity is negative, and I need to figure out what all these quantities mean. I basically just copied some of these things down from above. The mass is 45.5 kilograms. Negative 24.0 meters per second is the speed at the beginning of this situation, and then the ending speed is zero. And so the initial velocity is negative 24.0 meters per second. The final velocity is zero. And the force acting on the parachuter, not parachute, the stuntman, is 2350 newtons. And that's a direction as well. It should include a direction too. So, what kind of force is acting to stop this man? It's going to be he's moving down, but he's coming to rest. So, there must be some force acting this direction, which would be the positive direction. So, it's good to keep this as a positive 2350 newtons. So now we're going to be solving for, it says, what stopping time is needed to safely bring the man to rest. So we need to know how much time is going to need to go by here to make sure that this force is 2350 and that the person is safe. So we're going to be looking for time, and we need to start setting up our equation now that has the different relationships that we need. If we look at our big equation here for impulse and change in momentum, the only one that has time in it is this one. So we're going to start with force times time for one half of the equation. And the other half of the equation we'll choose based on our other given information here. We have mass and velocity, so we're going to be using this as our second part of the equation. So mvf minus mvi. Okay, now we're ready to start substituting in the numbers that we've gathered. So the force is 2,350 newtons. The time is our unknown. Mass is 45.5. The final velocity is just zero. Initial velocity is, the mass is 45.5 again. And the initial velocity is negative 24.0 meters per second. All right, so we're going to simplify this a little bit. Oops. So this goes to zero right here, zero minus, and then 45.5 times negative 24 is 1,092. We'll round that to have three significant figures, so we'll round the 2 down. It'll just be 1,090. And that's going to be in Newton seconds here. It's negative because the velocity was negative. So we have 0 minus negative 1090, which just turns it into a positive 1090. So 2350 newtons times the time is equal to, now it's positive 1090 Newton seconds. Okay, so now we're going to solve for the time by undoing this multiplication on the left by dividing. All right, so how much time does this take? So 1090 divided by 2350. So it's less than half a second. It's pretty quick. We'll need 3 sig figs here, so it's going to be 0.464. So the time value is 0.464 seconds. That's how long the cushion should be acting on the man to slow him down. So that's all I've got for you in this video. Remember, a bad attitude is like a flat tire. You won't get anywhere until you change it.